Am I audible?
Yes, sir.
Okay. So now, yesterday we were mainly discussing about the. Okay. Yesterday we was mainly discussing about the measurements. Okay, measurements of surface roughness, gauging, then measurement of screws, various types of screw gauge threads, all that things. So I hope so you remember everything. So and we were discussing the various measuring instruments used for that. So again, we are in the advanced measuring instruments. So there are various advanced measuring instruments. Okay, now in this module we are mainly going to discuss about the advanced measuring instruments, where the most commonly used advanced measuring instruments are laser interferometers, coordinate measuring machines, CMM, all that. By that we will be completing this topic, completing the end of this module, and also the topic. So we are going to start with a topic which is named as advanced measuring devices, where the advanced measuring devices is mainly with the prospects or mainly with the arrangements, like what we can say is like it is mainly regarding, okay, it is always mainly regarding the what, it is mainly regarding the various devices which is used for the certain types of surface measurements or measurements. So it may be in the interferometry or principle of superficial or laser interferometry or CMM, that is coordinate computer measuring, all that will be happening. So before that we will have a basic idea of what you mean by the measurements and surface finish everything, then we will go to the. So mainly we can say the what you mean by the advanced measuring instruments is like, we can see it is named as, I can name it as laser interferometers, which we will be studying, then machines and metrology, then CMM. I hope so you know what you mean CMM, it is coordinate measuring machine, that is a separate topic which we will be discussing. Then we have the application, machine vision, then types of CMM, all that we will be learning. So what we are going to say is like, first we will start with an basic thing of interferometry. Okay, so the phenomenon in which, okay, mainly it is the phenomenon in which two waves, okay, the phenomenon in which two waves from a resultant wave of a greater or lower amplitude is called interference. I hope so you know what you mean by interference. It is the phenomenon in which, mainly in the case of wheel status, this will start with the advanced measuring in instruments with the, and what you mean by interferometry. Okay, what do you mean by interferometry? So what is mean by that is like the phenomenon in which two waves form a resultant wave of greater or lower amplitude is called interference. So here in the case of measurements of surface fields, we have certain types like stylus, probe, etc. So yesterday we were talking about the stylus. Can any one of you tell me where did we mark yesterday stylus? Yesterday also we had the last hour, so I hope so it will be fresh enough. So can you tell me where did you find the stylus yesterday? We are discussing about stylus. Anyone of you can say. Karthik, do you remember where were we missing? Where were we describing about the stylus yesterday? Karthik, are you available there?
Sir.
Okay. So yesterday where were we discussing about the stylus?
The
Hmm.
tablet, sir.
Hmm? No, it was not in the lab. It was regarding where we were discussing about the stylus. I am asking. Yesterday in one topic we were telling. So my question is, in which topic it was we were discussing about the stylus? That's what my question. Can or
Yes,
else
sir.
can any one of you say? If Karthik, no problem. If you don't remember, can any one of you say where did you find it? Okay. So it was in the. where it was in the Taylor system. Okay, I'll show you where it was. Like it's in the Taylor system, the stylus. Okay, so this were all this the threads. Okay, the bench diameter and here in the case of two piece and screw pitch because we were discussing about the stylus. Okay, so what is the purpose of stylus? All that we will be discussing. Okay, so what I was going to say is what is the purpose of a stylus in this case? Okay, so it was mainly discussed about the screws and threads and everywhere in the measurement of threads. Okay, regarding the helical and the dimension things, all that stuff. So now today we are going to say about the advanced measuring devices where we are named it as first one is named as interferometry. So in the case of interferometry, okay, in the case of interferometry, what happens is like, okay, the phenomenon in which two waves form a resultant wave of a greater or lower amplitude is called interference. Okay, then the various measurements used for that are stylus probe instrument. That's a contact type. So these method enable to determine a numerical value of the surface finish of any surface. So it is the main purpose of this method is a stylus probe instrument. It is of a contact type. It's just got a skid and a pickup and stylus plate on the surface. So the stylus is help for measuring the surface. So see, this is the stylus which sits on the surface of the material which has to be measured or which is required for measurement. So in this case, what happens is these methods enable to determine a numerical value of the surface finish of any surface. Okay. In this method, what happens is this method enable to determine a numerical value of the surface finish of any surface. Then skid or shoe, which is drawn slowly. Okay, skid or shoe, which is drawn slowly over the surface, either by a hand or a motor. Okay, either by a hand or a motor or by a motor drive. The skid, when removed on the surface, follows its general contours and provides a datum for the measurement. So this is what happens when the measurement is surface stylus probe measurement contact type where these methods mainly enable to determine a numerical value of the surface finish of any surface. And skid or shoe, which is drawn slowly, it's always drawn slowly over the surface, either by a hand or by a motor drive. So you should draw a line. We most probably will be using a motor drive or by a hand, where the skid, when moved over the surface, follows its general contours and provides a datum for the measurements. Okay. Then a stylus or a probe which moves over the surface with the skid, where stylus or a probe which moves over the surface with the skid, where the stylus should be a cone shaped with a spherical tip. This records the microgeometrical form of the surface. Then it moves vertically up and down relative to skid movement due to the roughness of the surface. So a stylus or probe which moves over the surface with the skid. Okay, it mainly consists of a stylus or probe. Okay, mainly consists of stylus or probe which moves over the surface. Stylus or the probe is always which moves over the surface with the skid, where the stylus should be cone shaped, where the stylus should be cone shaped with a spherical tip. So the stylus should be a cone shaped with a spherical tip. This records the microgeometrical form of the surface. So this records the microgeometrical form of the surface. Then it moves vertically up and down. Okay, it moves. What happens? It moves vertically up and down relative to skid movement due to the roughness of the surface. So in the case of stylus, what happens is a stylus or a probe. Okay, a stylus or a probe which moves over the surface of the skid, where the stylus should be always the cone shape. But stylus should be always the cone shape with a spherical tip. So this records a microgeometrical form of the surface. Mainly it records a microgeometrical form of the surface where it moves vertically up and down relative to skid movement due to the roughness of the surface, according to the roughness of the surface. Then, as the stylus tracks the surface peaks and valleys, tracks the surface peaks and valleys, its vertical motion is converted to a time varying electrical signal that represents the surface profile. So what happens is as the stylus tracks the surface peaks and valleys, its vertical motion is converted to a time varying electrical signal that represents the surface profile. Then generally it is decided that if the skid is moving up, then the stylus should must be also moving up. Generally it's decided that when the skid is moving up, the stylus should also move up. So this is what the movement. Okay, this is see the transverse. This is the transverse direction, and this is the skid. So and this is the stylus movement where we can see the surface. So this is the skid. This is what happens in the diagram. Then the second one is named as profilometer. Okay, the second one is named as profilometer. I hope so. You're just noting down the names at least that. So the second one is named as profilometer. Okay, the second one is named as profilometer. So, what do you mean by the purpose of a profilometer? Okay, so profilometer means what happens is it is mainly regarding the measurements. Okay, it's mainly regarding the indicating and the measurements, indicating and record the instrument used to measure the roughness in micron. That's the measurements. That's the one word we can say. It's the measurements of roughness in microns. That's what we say. So, what happens over here is okay. You see the stylus or a probe also available. So, so the stylus, okay, it is a material which is used for touching the surface to see the surface roughness or surface material or surface dimensions. Everything can be measured. So second one is the profilometer, that is a contact type. It is always the indicating. It is indicating and recording instrument used to measure the roughness in microns. Okay, it is indicating and recording instrument used to measure the roughness in microns. Okay, it is indicating and recording instrument used to measure the roughness in microns. Then it consists of two units, tracer and amplifier. It mainly consists of two units, that is the tracer and amplifier. Where okay, it mainly consists of two units, that's a tracer and amplifier. Okay, so what happens is like tracer is a finely pointed stylus. Okay, what do you mean by tracer? It is a finely pointed stylus mounted in the pickup unit. Okay, tracer is a finely pointed stylus mounted in the pickup unit, which consists of an induction coil. Okay, which mainly consists of an induction coil located in the field of permanent magnet. So what happens in the case of profilometers? It is indicating and recording instrument. It's mainly an indicating and recording instrument. Okay, it is mainly an indicating and recording instrument used to measure the roughness in microns. It is mainly used to measure the roughness in microns. It is mainly used to measure the roughness in microns. So then it consists of two units, tracer and amplifier. It mainly consists of two units, that's the tracer and amplifier. So what happens is tracer is a finely pointed stylus mounted in the pickup unit, okay, which consists of an induction coil located in the field of permanent magnet. So when tracer stylus is moved across the surface to be tested, it is displaced vertically up and down due to the surface irregularities. So this causes induction coil to remove in the field of permanent magnet and induces the voltage. The induced voltage is amplified and recorded. This is what happens in this case. So what happens is like, okay, this is what happens is in this case, what happens is like where it has got a profilometer that is of a contact type. So what happens, it is indicating and recording instrument. It's an indicating and recording instrument used to, okay, it is indicating and recording instrument used to measure the roughness in microns, used to measure the roughness in microns. So it mainly consists of two units, tracer and amplifier. It mainly consists of two units, tracer and amplifier, where the tracer is always finely pointed stylus. Okay, it is a very finely pointed stylus mounted on the pickup unit. It's mainly mounted on the pickup unit. This is what we say. Okay, this is mainly mounted on the pickup unit. This is stylus, which is mounted on the pickup unit, which consists of an induction coil located in the field of permanent magnet. Okay, it is always consists of an induction coil located in the permanent magnet. So when tracer stylus is moved across the surface to be tested, it is displaced vertically up and down. It is always displaced vertically up and down. Okay, due to the surface irregularities. It is mainly due to the surface irregularities. Okay, then this causes induction coil. This mainly causes induction coil to move in the field of permanent magnet and induces the voltage. The induced voltage is amplified and recorded. Okay, the induced voltage is amplified and recorded. Then what happens is when the profilometer moves, okay, when the profilometer moves on the surface of the work, the stylus gets vibrated. So what happens is when the profilometer moves on the surface of the work, the stylus gets vibrated. The stylus gets vibrated, and the surface is not smooth. It is not smooth, and this vibration occurs in it transferred to the coil. So what happens when this vibration is okay, it occurs in the and transfers to the coil, which is always present in the magnetic field. You have to consider the magnetic field with the help of a galvanometer, where the measurement is done due to the induced current. Okay, so this is what happens in the case of a profilometer, where it is an indicating and recording instrument used to measure the roughness in microns, and it consists of two units, that is tracer and amplifier. So in the case tracer is finely pointed stylus, and it consists of induction coil of field per magnet, while the tracer, okay, then the tracer stylus is moved across the surface to be tested and displaced vertically up and down due to the surface irregularities, which causes the induction coil to move in the field permanent voltage. the induced voltage is amplified and recorded. Okay, then what happens in the case of profilometer is, what happens in the case of profilometers, the profilometer moves on the surface of the work. Okay, so you see, so automatically what happens is the profilometer when moves on the surface of the work, this is the machine surface, moves on the work, the stylus automatically what happens, the stylus gets vibrated due to the uneven surface, and when the surface is not smooth, the stylus gets vibrated, and this vibration occurs and is transferred to the coil which is present in the magnetic field with the help of a galvanometer, and the measurement is done due to the induced current. This is what happens in the case of a profilometer. Then comes a Tomlinson surface meter. That's irregularities are magnified and shown on a smoke glass. Here, what happens is the mainly the irregularities are magnified and irregularities are magnified and shown on a smoke glass. So you see, here also what we will be having, we will be having a stylus, this is a machine, this is a diamond probe, okay, then this is the load steel cylinder, leaf spring, arm, body, horizontal motion of the body, vertical motion, rollers, everything is available in the case of a Tomlinson surface bar. Okay, so actually it's named as Tomlinson because this instrument was designed by Mr. Tomlinson. Okay, so this is, in this case also we will be having a spring. So fixed rollers, vertical motion of stylus, do a waviness stylus, diamond prop. So I hope what you remember what you mean by waviness. Okay, can anyone if you tell me what you mean by waviness? We have already discussed the starting of the model, not in starting, regarding the surface roughness. When we are discussing about the surface roughness, we were discussing about waviness and roughness. Can anyone if you tell me what you mean by waviness? Agilam, can you tell me what you mean by waviness? Okay. Agil?
Sir,
Ah, yeah. Can you tell me what do you mean by waviness? Since we are discussing the waviness over here, this we have already discussed in the case of surface roughness. Do you remember the surface roughness where we had a comparison with roughness and waviness, everything? Just
uh,
2 or 3 class before. Yeah, that's what. This week itself, I think so. Monday, I think so. Regarding the surface roughness.
surface tech.
Hmm? Anyone else? Okay then,
Sir,
Rahul Rajiv. Can you tell me what do you mean by waviness?
that is the uneven,
Yes.
uh,
Uneven.
uh, continuous uneven
Yeah.
structure.
Okay. Yeah, it is always related to surface roughness. Okay, thank you. Okay, but it's an uneven surface where we have to measure and understand what is the values, everything. So that's what we say. It is always regarding the surface roughness also. Okay, sir. So basically, you can say like that also. Okay. So that's what happens with respect to the waviness. Okay. What happens is we have got a fixed rollers, vertical motion of the stylus due to waviness, stylus diamond probe. So we can measure the uneven with the help of a stylus, and we have a spring which is have to absorb the vibrations and understand what is the difference. This is what happens, and this is smoke glass and diamond tip where we understand what is the difference. See, and it will be shown here. The graph will be plotted here regarding the unevenness on the surface. So this is what happens when with respect to what happens a Tomlinson surface meter. You see this now. See, this is the basic representation. See, so let's see. I hope so. You're seeing the basic representation. So this is the. Okay, can anyone say what is this? What do you mean by this? Where I am moving the cursor. What do you mean by this? The case of Tomlinson surface meter. What do you mean by this needle? Agash came at least this one. What will be that?
സർഫസ് മീറ്ററിന്റെ
Uh, what we name it this one? This is the surface of uneven surface of a surface body with a machine part. Okay, I hope so you understand. And what do you mean by this one? This one's what? What is the instrument used to measure the uneven surfaces of the things over here? Today we were discussing about the advanced measuring instruments where we are telling about a component. What is the name of that component?
measuring instrument
It's a device called stylus.
style.
with the help of stylus, and this is the arm. Okay, you see. So you see here, see, this is the stylus, the same thing. This is the stylus you have seen. See, this is the wavelength. Stylus is used to measure the uneven surfaces helping skid plate, and this is the arm which transfers this motion. Okay, so this arm is required, and with the help of a diamond flow glass, it gives a wavelength. Uneven surface of here will be moving, and this is what the representation. You see this now. Now you look over it and you understand. See, when it's moving up, it is showing a reference. So the graph is being plotted in the smoke blast over here. That's what. So what happens here is LCR construction where we have a diamond stylus on the surface finish recorder. Okay, we have a diamond stylus which is on the surface finish recorder, which is held by the spring pressure against the surface of a lapped steel cylinder. So what happens here is we have got a diamond stylus on the surface finish recorder, which is held by spring pressure. It's always held by spring pressure against the surface of a lapped steel cylinder. Against the surface of a lapped steel cylinder. Then the stylus is also attached to the body of the instrument. The stylus is also attached to the body. Okay, the stylus is also attached to the body of the instrument. The stylus is also attached to the body of the instrument by a leaf spring, and its height is adjustable to enable the diamond to be positioned conveniently. So what happens here is the diamond, okay, the diamond stylus on surface finish recorder is held by a spring pressure against the surface of a lapped steel cylinder. So what happens is we have got a diamond stylus over here on the surface finish recorder, which is held by a spring pressure. It's always held by a spring pressure against the surface of a lapped steel. Okay, against the surface of a lapped steel cylinder. Okay, against the surface of a lapped steel cylinder, where the stylus is also attached to the body of the instrument, where the stylus is also attached to the body of the instrument by a leaf spring. Okay, whether the stylus is also attached to the body of the instrument by a leaf spring, and its height is adjustable to enable the diamond to be positioned conveniently. Okay, so in the case of a stylus, it is also attached to the body of the instrument by a leaf spring, and its height is adjustable to enable the diamond to be positioned conveniently. And the height is adjustable to enable the diamond to be positioned conveniently. Then what happens is the lapped cylinder. Okay, the lapped cylinder is supported on one side. Always the lapped cylinder is supported on one side by the stylus and on the other side by the two fixed rollers. Okay, so see, this is what we are saying. Okay, this is a lap cylinder. On the This is the lap cylinder, two fixed rollers, and one stylus. This is what happens. So this is what we say in the construction. So here what happens is the lap cylinder is supported on one side by the stylus and on the other side by two fixed rollers. Then the stylus is restrained from all motions except the vertical one by the tensions in coil and leaf spring. Okay, what happens is the stylus is restrained from all motions. Okay, the stylus is restrained from all motions except the vertical one by the tensions in coil and leaf spring. Okay, what happens is the stylus is restrained from all motions except the vertical one by the tensions in coil and the leaf spring. Okay, then the tension forces in these two springs also keep the lapped steel cylinder in position between the stylus and a pair of fixed rollers. Then what happens is a light spring steel arm is attached in the horizontal lapped steel cylinder and carries a diamond tip scriber with the beers. So this is what happens with. So I have read that. So before that, just have an overview of this figure. Okay, what are the parts when we are discussing about the construction? Okay, what are the parts available when we are discussing about the construction? Just have an overview. Okay, just note down what all is there. If possible, just draw the figure also. Okay. So I hope so you have seen the figure. Okay, I hope so you have seen the figure over here where we have a Tomlinson surface meter, and this was the construction which I was discussing about. So you see a diamond stylus on the surface is recorded by held by spring pressure against the surface of a lapped steel cylinder. So the diamond stylus, you can see this is the diamond stylus spring recorder. Okay, that's what the first point. The second point was like, see, the stylus is also attached to the body of the instrument by a leaf spring, and its height is adjustable to the diamond to be positioned conveniently. See, the leaf spring. So, see horizontal body of the motion which is attached to the leaf spring, and a diamond rhombus to adjust the position conveniently. That's what we are saying. Then the third point, the lap cylinder is supported on one side by the stylus and the other side by two fixed rollers. So see, the lap cylinder is always fixed by two fixed rollers and one side by the stylus. This is what we are seeing. Then what happens? Third one is what? Okay, the stylus is restrained from all motions except the vertical one by the tensions in coil and the leaf spring. The stylus is restrained from all motions. Okay, the the stylus is always restrained from all motion except the vertical one. See, so only the vertical one. Vertical motion is only available. The rest everything is restrained. Okay, that's what the stylus is restrained from all the motions from the vertical one. The tensions of coil leaf spring. Then the tensile forces in these two springs also keep the lapped steel cylinder in position. Okay, the tensile forces. Okay, the tensile forces in these two springs. Okay, the tensile forces in these two springs also keep the lapped steel cylinder in position between the stylus and a pair of fixed rollers. That's what happens. So what happens is the tensile forces. Okay, the tensile forces in these two springs also keep the lapped steel position in cylinder. So the tensile forces has been created in these two springs. Okay, see, and the tensile forces will be produced over here. What happens is in the leaf spring and string, the tensile forces produced in these two springs also keep the lapped steel cylinder in position between the stylus and a pair of fixed rollers. So what happens? So that the lapped steel will be always cylinder present between the stylus and the fixed rollers. That's what we say. Okay, the fixed rollers. Then a light spring steel arm is attached to the horizontal lapped steel cylinder. Okay, it carries a tip of a diamond scriber, which bears against a smoke glass. So what happens? A light spring steel arm is attached to the horizontal lap steel. See, spring arm is attached to the horizontal lap steel. Okay, this is the diamond steel tip, the smoked glass. Okay, that's what we see. So a light spring steel arm is attached to the horizontal lap steel cylinder and carries as a tip a diamond scabbard which bears against the smoke glass. Then any vertical movement of the stylus is caused by the surface irregularities causes the horizontal lap steel cylinder to roll. That's what happens. So in the case of working, what happens? Any vertical movement, okay, any vertical movement of the stylus which is caused by the surface irregularities, okay, it's always the any vertical movement of the stylus which is always caused by the surface irregularities causes the horizontal lapped steel cylinder to roll. It mainly causes the horizontal lapped steel cylinder to roll. Then by its rolling, the light arm attached to its end. By its rolling, the light arm attached to its end provides a magnified movement on a smoked glass plate. So what we are saying, this is what we are saying about. See, in this case, what happens? In this case, this is what we are saying about. Okay, this is what, in this case, this is what we are saying about. See, this is the case. That's what we're saying about. So what happens is like by rolling the light arm attached to its end provides a magnified movement of smoke glass plate. Then the smoked glass trace is then further projected into 50 or 100 magnification for examination. So this instrument is comparatively cheap and it gives a reliable result to an extent. So what happens is this, okay, what happens is this instrument is comparatively cheap. So this instrument is always comparatively cheap one and gives almost reliable results. That's what happened, and almost gives reliable results. This is the smoke glass traces and further projected to X50 or X100 magnification examination, where this instrument is comparatively cheap and one gives relative results. Then comes the Taylor-Hobson's Taylor surf. Okay, this is what happens. The Taylor-Hobson's Taylor surf. So what happens over here is what it's like. Okay, in the case of Taylor, it is an electronic instrument mainly used for measuring the accuracy of the instrument. It is mainly used for measuring the accuracy. It is mainly used for measuring the accuracy of the instrument. Okay. So what we have is here we have a E-shaped arm, armature, everything. Again we have a stylus where what is used for, and we have a skid plate in order to measure the uneven surfaces. Okay, uneven surfaces, and to understand what is the difference. Okay, and what we, and so then it will be converted with the help of an what resistor and a capacitor and amplifier and demoder and recorder, filter, meter, all the components are used in order. But this electronic instrument is mainly used in order to provide a very accurate and precise dimensions or the unevenness in the surface. That's what mainly regarding the unevenness in the surface will be produced. Okay, mainly the unevenness in the surface will be produced with the help of a Taylor-Hobson scale surf, electronic instrument widely used in advanced measuring instruments. Since it's comparatively bit expensive and compact, but what happens is it will be giving a better aspect range. Okay, better aspect range. That's what happens. And also what happens is the it also helps to identify the measurements of length and small changes in length. Then optical testing can be done. Then it also studies of the surface structure. Then measurement of
Hello.
Sound good.
ah, students, could you hear me? There's a small network issue.
Yes, sir.
Okay, so okay, fine. So there's a small network issue. I hope so. It has been restored. Okay, it has been restored. So yeah, like we were talking about. Okay, what we were talking about is what we were talking about is was regarding the okay was mainly regarding the tailors. Okay, Taylor Hobson Tailor, where it has an electronic instrument which is accurate. Okay, it's an accurate electronic instrument device where we have got an measurements of length and small changes in length and small changes in length, optical testing, then studies of surface structure, then measurement of pressure and temperature difference in gas flows and plasma. And then what happens is measurement of particle velocities and vibration amplitudes all are measured. Then the wavelength of the measurement, all this will be measured with respect to the what happens. Okay, Taylor. Okay, the Taylor strength measure. Okay, so this is what happens with respect of the Taylor Hobson scale curve, where we have the various measurements required. Okay, that's what happens over here. So what happens over here is like the mean. Okay, the measuring head of the instrument consists of a diamond stylus. Here, what happens is we have a measuring instrument. Okay, so the measuring head of instrument consists of a diamond stylus of about 0.002, okay, 0.002 mm tip radius, and a skid or a shoe, which is drawn across the surface by means of a motorized driving unit. Then the arm carrying the stylus, okay, then the arm carrying stylus forms an armature which pivots about the center piece of E-shaped stamping. Okay. On two legs outer pole pieces, the E-shaped stamping, there are coils carrying an AC current. So these two coils with the other two resistance form an oscillator. So what happens over here in the construction is the measuring head of this instrument, okay, mainly the measuring head of this instrument consists of a diamond stylus. Okay, here what happens over here is the measuring head. The measuring head of an instrument consists of a diamond stylus of about 0.002 mm tip radius and skid or shoe, which is drawn across the surface by means of a motorized driving unit. Then what happens is the arm carrying the stylus, mainly the arm, it is the arm carrying the stylus forms an armature which pivots about the center piece of E-shaped stamping. So what happens is here we have an arm, the arm carrying the stylus, which forms an armature which pivots about the center piece of the E-shaped stamping. Then on two legs of the outer pole pieces, okay, on the two legs, mainly on the two legs of the outer pole pieces, the E-shaped stamping, there are coils carrying an AC current. Okay, that's alternating current. The two coils with each other to resistance from oscillator. So in this, what happens is in the case of Taylor Hobson's Taylor surf happens is it's an electronic instrument used for the meaning of accuracy of the measurement. So in our application, what happens is mainly used for the accuracy, measuring the accuracy of the measurement. Okay, so it gives a better rate of accuracy when compared to the other. That's why it comes under the advanced measuring instrument devices. So where we are having the measuring instrument, the head consists of a diamond stylus. Okay, the tip will be diamond stylus of about 0.002. The stylus is the compound which is used to touch the surface, which is to check whether it's irregular or regular or any other deformations are taking place. All this will be measured. The, the component of the measuring device which has a direct contact with the surface, which has a component is always the stylus. That is the on the surface of the component. That's what happens. So what happens? That's what happens in the. So what happens here? We have put a skid or a shoe, which is drawn across the surface by means of a motorized driving unit, where the arm carrying the stylus, the arm carrying the stylus forms an armature which pivots about the center piece of a E-shaped stamping. So what happens is here we have an arm carrying the stylus, which forms an armature and which pivots about the center piece of the E-shaped stamping. On two legs, on the two legs of outer pole pieces, the E-shaped stamping, there are coils carrying an alternating current or AC current. On two legs of the outer pole pieces, the E-shaped stamping, there are coils carrying an alternating current where these two coils with other two resistance form an oscillator. Okay, so where these two coils with other two resistance form an oscillator. Now the armature is pivoted about the central leg. The armature is pivot about the center leg. Any movement of the stylus, okay, any movement of the stylus, and as armature is pivoted about the center leg, any movement of the stylus causes the air gap to vary, mainly causes the air gap to vary, and thus the amplitude of the original alternating current flowing in the coils is modulated. So what happens over here is here we have a working, okay, where an armature is pivoted about the central leg. Okay, so what happens is here we have an armature which is pivoted about the central leg, and any movement of stylus causes the air gap to vary, and thus the amplitude of the original alternating current flowing in the coils is modulated. This is further demodulated so that the current now is directly proportional to the vertical displacement of the stylus only. Then the demodulated output is caused due to operate of a pen record to produce a permanent record, and which where the meter gives a numerical assessment directly. This is what happens over here. Okay, so these are the various methods or various techniques of the advanced measuring instruments. Okay, there are today we are discussing four numbers and the recording. I'll just stop for today. Okay.